Okay, I got cut off there. So this is part 2, and sorry about that. So I'm going to finish this problem where we factored out a -1, or you could say divided by a -1. All right, x squared plus 6x, and I move the -7 all the way over. Completing this square means I take half of 6, which is 3, and then squaring it, which is 9. So I'm going to add 9 and subtract 9. Remember, 6 over 2 and then squared equals 9. Okay, factoring this is going to be x plus 3 squared, and then we have minus 16 on the outside. And we're not quite done because remember on the left-hand side we have y over -1. So I'll multiply everything by -1 to get y here by itself. So this is -1 times x plus 3 squared, and then -1 times a minus 16 is plus 16. Something else we did in class was graph this. So make a really big graph. The vertex is at -3, positive 16. So I'm going to need to make my graph go all the way up to 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then I have to go over at least -3 to get to the vertex. Notice that in a vertex form we have a minus out in front, this minus a. We also have the minus a here, so this parabola is going to open down. All right, plotting the vertex is -3, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now some of you might have some different notes. I did different problems in each class, but this is the notes I'm doing right now, so hopefully it helps. So there's a vertex, and instead of following the pattern of going over 1, up 1, over 1, up 3, over 1, up 5, this -1 tells us, this negative in front tells us to go over 1, down 1, over 1, down 3. So I'm going to go over 1, down 1, down 1, over 1, down 3, over 1, down 5. 1, 2, 3, 4, 5. Should end up at 7. 1, 2, 3, 4, 5, 6. Right here. This is a really rough sketch. You can do one of these in your homework, and hopefully you'll do it a lot better than I just did. And there is the sketch. Oops, there's the sketch of the parabola. Using the vertex of -3, 16 up here, and then using the pattern of not over 1, up 1, over 1, up 3, over 1, up 5. We're going to go over 1, down -1, over 1, down -3. Okay. All right, so that was the notes. I'm going to do a couple of the homework problems for tonight. So let's see.
Sarah Garcia.
Number 1 on the homework for Friday night. We did some of these in class. I'll go ahead and do number 1 again. We're changing these quadratic equations into the vertex form. And we can do that as long as we make the leading coefficient 1. And I'm noticing that this is 2, so I'm going to need to factor out a 2. Another way of looking at that would be dividing everything by 2. So let's just do it that way. Y over 2. Everything by 2. So this becomes x squared. This becomes plus 4x. This becomes minus 2. Now I have a leading coefficient of 1. So we can factor, or complete the square to factor. The perfect square trinomial. X squared plus 4x minus 2 moved over here. Half of 4 is 2. 2 squared is 4. I'll add 4, subtract 4. My perfect square trinomial now can be factored. Square root of x squared is x. Square root of 4 is 2. 2 pluses, so that's a plus in the middle. squared outside. X plus 2 squared will give us this. Minus 6 on the outside. And then the last step is just to take that 2 that we divided everything by and multiply everything back by 2. So y equals 2 times x plus 2 squared minus 12. And the vertex can be easily found from that. So go ahead and circle that. You don't have to rewrite it if you don't want to. But I want to see your vertex form very clearly. And then your vertex here is the opposite of 2, so it's minus 2. And then we take this negative 12, okay, put that there. Okay, I'll do number 4. Number 4, let's put this into vertex form. However, let's make this a 1 first so we can do it. Divide everything by negative 2, so y divided by negative 2 equals x squared minus 2x plus 3. If I divide that by negative 2, I get minus 2x. And divide that by minus 2, I get a positive 3. Okay, now we can complete the square. X squared minus, we'll put the plus 3 all the way over here. X squared minus 2x with the plus 3 over here. Half of 2 is 1. Even if you say half of negative 2, it doesn't matter if you take that negative. Half of negative 2 is 1, negative 1. Negative 1 squared is 1. You're always going to be adding a positive number there, but then subtracting it to compensate. Factor the first perfect square trinomial. Square root of x squared is x. Square root of 1 is 1. And we have a minus and a plus, so we have to put a minus inside the factor and square it. Now the perfect square trinomial has been factored. And on the outside we have minus 1 plus 3 is plus 2. We're not quite done. We still have y over negative 2. We divided everything by negative 2, so now let's multiply everything by negative 2. So we get negative 2 times x minus 1 squared. And then negative 2 times 2 is negative 4. Y equals, and that's the vertex form. Negative 2 times this, and then negative 2 times this is our final step. What is our vertex? 1, negative 4. Okay, number 6 is a fraction. So when you do this fraction, let's do this, let's start this, and I'll talk about it just a tiny bit. So this number here is 2. We'll need to divide everything by 2. So y over 2 equals x squared. Now x divided by 2, it's better if you write it like this. Instead of writing it as x over 2, write it as 1/2 x. So we have a coefficient. So x over 2 is 1/2 x. And then negative 2 divided by 2 is minus 1. So I just factored out or divided everything by 2. I'll rewrite with x squared plus 1/2 x and put the minus 1 all the way over here. What is half of a half? What is half of a half? Well, we could look at it like this. Here's a half of a pie. What's half of that pie? Well, that looks an awful lot like 1/4 to me. So half of a half is 1/4. So you have to take half of a half and then square it. Another way to look at half of a half would be 1/2 times 1/2. 1/2 of a half, and that's equal to 1 times 1 is 1, 2 times 2 is 4. So you can see half of a half is 4. 1/4. Half of a half is 1/4. So we take half of the half, and then we square it. So half of a half is 1/4. Let's square it. And so when you square it, it's the same thing as 1/4 times 1/4. I'll write that over here. 1/4 times 1/4. So 1 times 1 is 1. 4 times 4 is 16. Another way to look at it is square the 1 and then square the 4. So I'm going to take half of that, which is 1/4, square it, which is 1/16. So I add 1/16 and subtract 1/16. Well, how do I factor that perfect square trinomial? Looks like I'm going to do the whole problem here. How do I factor that perfect square trinomial? Well, I take the square root of x squared, and the square root of 1/16 is 1/4. What do I multiply by itself to get 1/16? 1/4. The square root of that is the same thing as the square root of 1 and the square root of 16. So square root of 1 is 1, and the square root of 16 is 4. So I put plus in the middle, and it's factored. X plus 1/4 squared. And then minus 16 minus 1. Well, there's a lot of ways I could look at that, I guess. Minus 1/16 minus, let's rewrite that as 16 over 16. So I get x plus 1/4 squared minus 1 minus 16 is minus 17 over 16. And I have got that equal to y over 2. So I'm not quite done. I need to multiply everything by 2. So what I can do is 2 times x plus 1/4 squared. I multiplied the 2 here out here. And then this times 2. What is negative 17 over 16 times 2? What is negative 17 over 16 times 2? Well, I can cancel here. 2 goes into 2 once. 2 goes into 16 8 times. I get negative 17 over 8. Minus 17 over 8. And that is the vertex form for number 6. Okay. When you graph number 7, first you're going to put it into vertex form. And you have to divide everything by 3 here. Put it into vertex form, find your vertex. You can find your y-intercept right from the standard form, or you can see if you can find it as you graph. Find your axis of symmetry. See if the vertex is a max or a min. We'll go through that again. Change this into vertex form by dividing everything by 3. Then change it into vertex form. It takes a little bit. Then find the vertex. Your y-intercept is right here from the standard form. Your axis of symmetry is the x-coordinate of the vertex. Determine if the vertex is a max or min, and see where the graph intercepts the x-axis. Those are your x-intercepts. Your x-intercepts will be where the graph intercepts here. Of course, this is all review. Lots of review on that graphing. So I'm going to let you do that, and I will see you on Monday. Have a super great weekend.